Standard enthalpies of formation. Write an equation for the formation of A, MgCO3 solid, and B, C6H12O6 solid from their elements in their standard states. Include the value of the standard heat of formation for each equation. We start by writing the product in its standard state. So in part A, that's magnesium carbonate, MgCO3, which is ionic and therefore is a solid. And we want 1 mole of the magnesium carbonate. And then on the left side of the equation, we want to put the elements that make up magnesium carbonate in their standard states. So we see we have oxygen, and oxygen occurs as a gaseous diatomic molecule, so we write O2 gaseous. We have carbon, and carbon occurs as a solid, and it is in the graphite form in its most stable state. So we write carbon, and then solid, comma, graphite. And then finally we have magnesium, which is a metal and is a solid. Because we want to have a 1 in front of the magnesium, we have to add coefficients to the reactants in an appropriate fashion. So we have 1 magnesium, we have 1 magnesium, 1 carbon, 1 carbon. But we have 3 oxygens in the magnesium carbonate, so we have to multiply the oxygen by 3/2. This is the defining equation for the formation of magnesium carbonate. And if we go to the textbook, we can find the value of the heat of formation in Appendix 2B, and that value is a negative 1095.8 kilojoules per mole. Doing the same thing for part B, on the right side we have C6H12O6 solid, and this contains the element oxygen, so we will write O2 gaseous. It contains the element hydrogen, so we will write H2 gaseous, because it also occurs as a diatomic molecule. And again we have carbon, and its most stable form is graphite, so we write carbon, solid graphite. And to maintain a coefficient of 1 in front of the product, we need to multiply reactants by appropriate coefficients. We have 6 oxygens in the product, so we need to put a coefficient of 3 in front of the oxygen. We have 12 hydrogens in the product, so we need a coefficient of 6 in front of the H2. And we have 6 carbons in the product, so we need a coefficient of 6 in front of the carbon. So this is the defining equation for the formation of C6H12O6. And once again, we go to Appendix 2B in the textbook and look up the enthalpy of formation, and we find that it is also a negative 1,273.3 kilojoules per mole.